Hello everyone, today we are going to learn how to differentiate exponential function. Now, when we differentiate e power x, do you think the expression will be complicated? Actually, it's very simple. Okay, so look, when we differentiate e power x, we will get e power x. Surprising, right? But it's true. Okay, so this is the first thing that I want you to learn today. When you differentiate e power x, you will get back e power x. Alright, let's apply this on a few examples. We want to differentiate x squared e power x. As you can see, there are two terms here, x squared and e power x. So, when you want to differentiate two terms, what must come into your mind? The product rule. Okay, so examine this line carefully. We have done this many times, so I hope this is nothing new. So the first term will be x squared, and you differentiate e power x, you must get back e power x plus e power x. I hope you can recall how to differentiate x squared. Bring down the power 2 and then the power minus 1, so you get 2x. Now, all your answers must be simplified. You can see there is e power x on both sides, so you just factorize it out and you get the following. So far so good. There is nothing new here. We are just applying the fact that when you differentiate e power x, you must get back e power x. Just like in the previous lesson, when we differentiate sine x, we get cosine. When we differentiate cosine, we get minus sine. And when we differentiate tangent, we get secant square x. So same thing here. Let's proceed to another example. Now, we want to differentiate an expression over another expression. What should come into your mind? The quotient rule. You can apply product rule here, okay, but I want to use quotient rule for this example. So let's go through this slowly. So how should we begin? We bring up the 1 plus x and we differentiate e power x. Now, is it plus or minus after this? It's minus. So you leave the e power x alone and you differentiate the 1 plus x. And do not ever forget to square the denominator. Okay, so let's go through term by term. 1 plus x, and once again, when you differentiate e power x, you must get back e power x minus. Now, you are now going to differentiate 1 plus x. So, differentiate term by term. When you differentiate a number, you must get 0. When you differentiate x, you will get 1. So, 0 plus 1. So, this is what you get. Now, we need to simplify it. So, you can see there is e power x on both sides. So, just factorize it. Gather the remaining numbers and you get your final answer. So far so good. Let's proceed to example 3. You want to differentiate a function inside a bracket and there's a power outside the bracket. What is the first thing that should come into your mind when you see something like this? The chain rule. So how do we differentiate using the chain rule? Okay, I didn't say much about this, but in class you practice a lot. You must have noticed it. We start from the outside and then we go to the inside. The outside is the power 3. So what do we do to the power 3? We bring it down. And then the power u minus 1. And don't ever forget, you need to differentiate the things inside the bracket. Okay? People always forget this part. So from the outside, go to the inside. The inside is the things inside the bracket. So do it slowly. When you differentiate e power x, you get e power x. When you differentiate 1, you get 0. So combine it and you get the following. Take a moment to absorb this. Once again, nothing new here. It's just that when the d over dx meets the e power x, you must know you will get e power x. That's all. All the rules here are what you have learned and what you have applied in the previous lessons. Now, we all know exponential functions is not just e power x. So, what if we want to differentiate an exponential, but not power x, but some function in x? How do we go about doing this? Let me illustrate using an example. An exponential whose power is 5 minus 2x. Now, will the differentiation of this function be any different compared to differentiating e power x? The answer is yes and no. But still, this is an exponential function. The concept is still the same. When you differentiate exponential, you will get back the same exponential. Okay? Now, you must be feeling something. We must be doing something to the 5 minus 2x. And we are right. We need to differentiate the 5 minus 2x. So take your time to understand this. Okay, so what we did here is, when we differentiate an exponential, we still get back the same exponential. But we need to do something extra, that is, we need to differentiate the power. So keep on doing. When you differentiate 5, you get 0. When you differentiate 2x, you get 2. So 0 minus 2. And you get the following. So far, so good? Okay. Now, you must be wondering, is this different from differentiating e power x? Can we apply the same step here when we differentiate e power x? Actually, yes. Now, listen carefully. When we differentiate e power x, we still get e power x. And then let's say I want to differentiate the power. The power of e power x is x. When you differentiate x, you get 1. So that's why we did not include that step when we differentiate e power x. Okay, so we can apply the same step here to when we differentiate e power x. You still get the same answer. So what did we just learn? When we want to differentiate an exponential, but the power is not x, but some function in x, we will get the same exponential function. But we need to differentiate the power. Okay, please grasp this concept. We are now going to apply this on a few more examples. So let's go. I want to differentiate an exponential, but the power is x squared plus 1. So apply what we just learned. When we differentiate an exponential, we must get the same exponential. And now we must differentiate the power. So far, so good. So carry on. When you differentiate x squared, you must get 2x. And when you differentiate 1, you get 0. So your final answer is the following. Alright, now we want to differentiate e power 2x and assign x. How many terms are there here? There are 2, the exponential and the sign. So what must come into your mind when you see something like this? The product rule. Okay, so when we differentiate sine x, we must get cosine x. And now we want to differentiate the e power 2x. So what are the steps again? You get e power 2x, and then when you differentiate 2x, you must get 2. Okay, so simplify this. You have e power 2x on both sides and factorize it. Now, let's try something a little complicated. We want to differentiate a function inside a square root. Okay, many of you have your own ways of doing, but the best way to do this, convert the square root into a power. And we all know square root means power half. Okay, power half, not times half. So how do we differentiate this? Okay, use the chain rule. So we bring down the power half, and then the half you minus 1. Now, do we stop here? Of course not. We must differentiate the things inside the bracket. Okay, I hope this is straightforward. Okay, we start from the outside, which is a power half, bring it down, then the power minus 1. Okay, then we go to the inside, which is inside the bracket. So half minus 1 is minus half. Okay, now we want to differentiate two things here, the exponential and the x. So let's focus on differentiating the exponential. When we differentiate exponential, we must get the same exponential. And then we must differentiate the power. Okay, do not forget the plus x. So when you differentiate x, you get 1. So we have plus 1. Okay, be careful here. The plus 1 at the end there. Okay, that plus 1 at the end there is not inside the d over dx. So don't go and differentiate that plus 1 at the end. So continue. Now we want to differentiate the bracket 5x plus 1. When we differentiate 5, what do we get? When we differentiate 5x, what do we get? 5. When you differentiate 1, what do you get? 0. So 5 plus 0 is 5. And don't forget the plus 1. Okay, until here, I think if you are good and careful, you'll be able to reach here. Now, this expression can be more neat. Okay, it can be expressed into the following. So take your time and figure out how this is done. It's very straightforward. Okay, so far so good? Then very good. Okay, now there may be some misconception that some of you may face. Okay, focus on these two expressions. You want to differentiate e power 2x and x squared. Once again, on the left is an exponential. On the right is just an expression in x. These are two different things. When you differentiate an exponential, you must get an exponential. And then you differentiate the power. When you differentiate x squared, do you get back x squared? No, because x squared is not an exponential. So, just use your chain rule. What do? You bring down the power 2. And then the power minus 1. Okay, so please learn to compare and contrast between these two things. Do not confuse yourself. Let me end this lesson with the following. I only taught you how to differentiate e power x. And we all know e is a number. So, if I change the e to some other number like 5x, do we get the same answer? Okay, think about it. The answer is no. You get 5 power x, but you get another term. So, figure out. I'll give you a hint. Express 5 as a function of e. So consider it.